I think the biggest piece is going to be, bringing this AI, enabling AI and enabling humans to use tests and CI data to actually level up their code, to fix their flaky tests, to fix their broken things. I think that, just our initial tests of this in the lab have been amazingly cool. And I look forward to sharing more of those, videos and success moments, because when the agent can actually fix your flaky test in a way that you wouldn't even have thought of because of all that context, that's a miracle. That's magic. Yeah. And I think when you have those magical moments with AI, you're just like, this is great.
Eli, thanks a lot for joining me.
Thanks for having me.
Maybe we can start off, you can tell us what Trunk does.
Trunk, at the heart of it, we keep CI green. So our mission is to basically look at the entire part of the software development lifecycle. At the end, after the code is written, there's a long kind of gauntlet to get your code actually into your main branches, and that's where we step in. So engineering efficiency, developer productivity is what we've been focused on from the beginning. We want to basically make it easy for engineers when they think their code is ready to go into the repo to actually land it. And that has normally been a very expensive part of the process. So we have tools, we have a platform that basically takes care of engineers along that second step of the life cycle, what we call the outer loop. So the inner loop is handled lovely by things like Cursor and awesome agentic tooling to write code. But once that code is written, actually getting into the system is the next step. And that happens to be extremely painful for a lot of organizations. We build a flaky test tool that basically will monitor how things are behaving inside your CI system. So we can see when your automated tests are falling over and causing, basically unreliable signal and we kind of smooth that out. We also have a merge queue that basically manages the large number of pull requests basically trying to land at the same time to avoid conflicts there.
Yeah, and how did you end up coming to this problem? I guess it's something that strikes me as a deep problem, but is not intuitive to anyone who's just been coding away and on their own, checking in source control. At what size and scale is it relevant?
Yeah, this is extremely nerdy tooling. This is not something that anyone who just starts, in a CS program is going to need, because you only really hit this scale when you're looking at 30 engineers and up working the same repository. But once you get there and you start to have large amounts of integration tests and unit tests, those tests will get crufty. They're going to start to misbehave. And then your engineers are really going to be slowed down by kind of that automation loop. How I got into this, my career is pretty long. I started out at Microsoft for 9 years, then had a startup in between there, and then sold that startup to Google. I was at Google where I really saw just some of the best developer experience and developer life cycle that had ever been built. I was just amazed at how efficient it was to get code into the repo. And the monorepo at Google is giant. Google 3 is just insanely massive code repository, but also keeps the trains running nonstop. There's never a problem with it. And that was just an eye-opener. When I left Google, I went to Uber and I worked on self-driving cars there at Uber ATG. And we had 700 engineers there trying to build a self-driving car. And the hardest problem that the engineers ran into was literally just getting the code from pull request into the repo. So literally we'd have engineers that were just spinning their wheels for days trying to get changes into the system. And a light bulb moment went off. I was like, they are missing a massive amount of tools, obviously, that Google have built. Now, most companies are not Google scale. They definitely do not want to invest the tens to hundreds of millions of dollars it takes to build these tools to handle all this automation for them. So I saw an opportunity to say okay, what if we actually just took those kind of visionary tools that Google has built and other very large scale companies have built, Microsoft and Amazon and Facebook all have built internal tools. What if we built versions of those tools applicable to all other companies? And that's why we started Trunk.
Yeah, that makes a lot of sense. And then where did you approach the problem mostly from this, it's known good how to build a better merge system, or how did you figure out where to start and what was on the initial set of requirements for?
Yeah, I'd say at the beginning, we actually started out, I think more on the vitamin side of things. We built a code quality tool that was responsible for automating all the code quality static analysis tools that companies needed to run. And this was the business at that point, we saw that, most people don't want to take their vitamins. They don't want to eat their vegetables. It's very hard, from a business perspective, to sell people. Even though they all know the right thing to do, it's hard basically to get over the hump and send someone an email, be like, hey, don't you want to take your vitamins? And be like, no, not really. Like, I'm good, like we could work around that. And, so we look back at like, okay, what were actually the most painful parts of the developer flow? And we saw, merge queues had been built at large organizations. At Uber, we had a homegrown version of a merge queue, and it would literally back up, for days. Like, you might submit something into the queue on Thursday and then hope that it clears by Saturday or Sunday. And that was just miserable. And we looked at that in a solution and we said, okay, well, there are a lot of ways we can make this a lot faster, a lot better. So the second product we brought to market was this merge queue, which was heavily targeted to organizations at larger scale. We're talking now 50 to 300 to 1,000 engineers all working in a single repo, landing code. And we have on market the most enterprise-ready merge queue on earth. It's amazingly scalable, and it's basically the only thing that holds us back is GitHub's own rate limits and the ability to push pull requests in their own system.
Awesome. Yeah, I'd love to talk more about like the constraints and scalability and like how you built that. But I guess first, like, how do you think about like entering into a context where some is to what extent is like the quality of your ability to have leverage and giving them better merge queue solution related to like the hygiene already in the org and the testing and like slotting in when you're trying to provide a value prop that may be relative to the rest of their engineering organization?
Yeah, that's a great question. It's actually, so early on, who are the consumers, who are the buyers of a merge queue? It's people who have used a merge queue at large organizations that are like, we need a merge queue. It was like an educational problem for sure, to let people understand this is their solution. They need a merge queue. This is going to keep things rolling. Everyone has kind of, at a large enough organization, is familiar with like a build break, right? So the main gets broken, all of a sudden no one can build, and there's kind of like a code red, and no one in the organization can do anything until someone reverts the broken commit. This is super nerdy level stuff, but what'll actually happen is like whole organization kind of grinds to a halt until this thing gets fixed. And that pain, if you message to someone, hey, has this ever happened to you? They'll say yes. They'll be like, well, I have a solution for you. It's a merge queue. And this is like the get going. But as you said, there are, we kind of think about all of our customers are like snowflakes. Every single one of their engineering practices, their organization, how they lay out their CI, all of these things.
Even the concept of a broken build is like up to them, right?
Up to them, yes. Yeah. So I think that when we start to think about building products, not just for your own organization, but for every possible organization, the matrix of support and how you think about approaching their solutions becomes a big challenge, a design challenge, right? How do we build something that's going to basically work for everybody? And our merge queue is highly configurable. Basically, any knob that you might want to change, we have built as a knob that is exposed to the users with education of like how you might want to tune that. So the merge queue supports things like batching and concurrency and retries, and it has anti-flake protection built into it. All of these things are basically tunable so the organization can use the tool as they want it. Some organizations want to run all their tests on every single pull request. Some of them want to run a subset of things only on the merge queue because it's more expensive. And can tune that as well. So it's kind of like one of these things where you need to build for everybody, and you end up with a highly configurable, really cool tool. But it's like when the organization is adopted, we kind of say, okay, this is going to be like open heart surgery when we're actually going to turn this on, because you're going to go from everyone's just like, squash merging into main to, oh, actually, I'm going to have to go into this merge queue and things are going to be blocked, and there's a whole different workflow. So there's an educational component as well as people get onto it.
Yeah, but you need to be, but also like from your perspective, like you have to be able to support a breadth of like, both complexity and quality of like test harnesses and whatever.
It's insane.
Yeah,
and then you have to also build good tooling so people can understand through the product why something didn't go through the queue. Why did it get kicked out?
Yeah, because now it's like it's like their fault. Their tests are flaky, but now it's your problem.
Exactly. We take on, so we see ourselves really as like a member of the developer productivity team at these companies. And our goal is really to deliver solutions so that the first person on the front line of that org that's going to get pinged, hey, why'd this thing get kicked out? Can be like, oh, well, if you look at the UI, it says this thing got kicked out because it was in conflict with this other pull request, and that's why it was rejected. And they don't have to ping us for support. The tool will basically tell them, and they'll have more information and better analytics than anything they would build in-house, right? at the end of the day, if you're building dev tools to sell to engineering companies and your buyers are also engineers, they love building stuff. This is just like their natural thing. Is like, I want to build this. It'd be like, well, you might want to build this. It'd be fun to build it, but actually let me show you the breadth of this problem and how much support you're gonna have to do, and analytics and reliability and scalability. And then they're like, oh, well, maybe I'll just buy this instead. So we constantly, when we come up against the build versus buy discussion, we're making the argument, yes, you could build this. Obviously, you could build anything. It's not your core business, though. You don't want to be in the business of building a merge queue or building a system to manage your Flaky tests. You should do whatever XYZ company does. You pump out the widgets, and we'll take care of the rest.
Yeah, and that didn't occur to me until you mentioned it. But like suddenly, when you add complexity to your merge system, like legibility of the new system is like very, very important, because people need to understand like what is going on if they're going to be able to fix it, especially like in the failure modes that like you cannot resolve for them.
Yeah, absolutely. And I kind of love this. The transition also of the maturity of the product is that like early days, customer asks like, why did this happen? Might be like, oh, maybe we made a mistake. But now all of our run-up questions come in, why did this happen? Be like, oh, that's because XYZ. You guys did this thing. Or, oh, that's because GitHub is down. Because GitHub is always down.
And then I guess maybe like, so going back to like, so the performance and scale of this, like, I mean, give me a sense for like, what is hard about this technically when you had to dig into like, give me like how large these orgs are, how many commits are going through, like what it actually like looks like to have to be able to like arbitrarily test any permutation of like the order of, I don't know.
Yeah. So I know at its peak, our merge queue can move over 3,000 PRs in an hour. Right. So basically we are constrained by the ability to just create PRs at that rate. No one actually does that, but this is what we've load tested against. The issue isn't really about, at the end of the day, we're an orchestration layer. So if you have, infinite compute in your CI and you want to go, light every machine on earth to run your tests, you can go do that, and we'll have no problem, dealing with that scale. The complexity of the problem is really like, how do we do this efficiently and explain to the user why something happened visually, and also keep the thing running as quickly as possible because no one wants to burn all their money on CI. No one has infinite CI they could just scale up. It just doesn't exist. So instead we have to use those machines, with like as much as possible. So we do batching, right? So if like 10 PRs are about to go into the merge queue, just as a step back, like merge queues are basically designed to do predictive testing, like any pipeline, right? So pull request A and pull request B are inside the queue. When you submit A, well, that could just be tested against the front of the queue. But B actually we're predicting that A is also going to work. So when B gets tested, it gets tested with A as well. And that is basically how a merge queue can keep things moving efficiently without breaking what's happening in the main build. It's predicting what the future is going to be like. Well, with any pipeline system, as you might remember from computer science classes, like if you have to do a pipeline flush, very expensive. If you have like a 10 deep merge queue and something goes wrong, you're going to have to restart a whole lot of work. And that wastage is really what we're trying to minimize. So we can support things like batching, which will take A and B together and just test them out as one. And then on top of that, we have anti-flake system, where basically if A fails, normally in a merge queue, if A fails, we're just going to kick it out and start the whole pipeline over. But in our system, we actually say, okay, if A failed, well, we actually know that B is also testing A. So when B finishes testing and is also tested A, and if BA works, no problem. A was probably just flaky. So we can push that whole thing through. So these kind of magical knobs is what makes our merge queue actually able to pump through pull requests at high rate, even with the flaky system. And I say even with the flaky system because every single integration and testing system on Earth is flaky, has problems, and is unreliable. So we basically need to deal with all the jitter in the system, and we basically smooth out that curve.
Yeah, because at some level, like a lot of the value prop is like avoiding this like record scratch moment where everything stops.
That's right. Or nothing can get into the system.
Yeah, and so you have to balance like kind of being optimistic about like what happens next versus it actually all working and verifying, right? Yeah,
that's right. And the other thing that I think people hate about merge queues is that they hate waiting behind other people's work, right? So if you go make a doc change or you're changing something in the front end code and the thing ahead of you is in the back end code, you're like, my code doesn't even touch that. Why am I waiting behind this guy to get my code in? So our merge queue is actually dynamically parallel. So our merge queue understands how your different pull requests interact and whether they actually will have impact on each other. And we can basically in real time create dynamic pathways for your code to land. So we've seen, very large customers, have really cool graphs where they're submitting literally like, 5 to 10 PRs at the same time, but they're going to actually go into 3 or 4, distinctly dynamically created lanes to all merge simultaneously. So that's kind of like the most complicated, I'd say cool computer science part of our merge queue. It's a complex graph that basically understands dependencies and can do this dynamism in real time.
And we like actually on a per commit basis, you're doing analysis of like how they interlay before they.
That's right. Yes. So customers will basically tell us what we call impacted targets, but in reality, different build systems like Bazel or Buck or NX, they have awareness of how your code interacts. So since you have that dependency information, we can use that to basically understand the intersection of your pull requests and understand if they're affecting anything that are related. And then you have companies that will also just be like, my front end code lives in /front end and my back end's in /back end. And they'll just do glob patterns and they'll send us a list of like, this changed front end and back end, or this only changed front end. And then we build the information from that.
Yeah. And that, I mean, imagine even once you have this concept of interrelation, there's some art to like, how do we parallelize these things to make sure we get something that works?
Absolutely.
The next step.
Yeah. We actually had a customer write in just this last week, like, hey, this thing landed into the system and broke the build. How'd that possibly happen? It turns out, well, when they reported the impacted targets to us, they said there were no impacted targets. So they reported as none. And therefore we're like, okay, it can just go in and it can test, independently. So that was a bug where they didn't report us. They didn't tell us what was actually affected. But in general, like it's amazing that this thing's been running, for years now, and we've had no issues where there has been a breakage introduced by this system. So it's quite reliable if the data is correct.
And having used these systems before, or like some version of them, like Google, and like going to build it yourself, were the things you found particularly surprising, or like that jumped out as like this is harder than I expected? Or
I think the hardest part, like with most integration problems, is all your other external dependencies.
Yeah.
Like
the breadth of actual users, like Google at least is in a context where they know the rest of the code convention, and
and they control their hardware, they control their webhooks, they control all the information. Like for us, since we're an orchestration system for this product, we're relying on GitHub, relaying to us webhooks in a reliable, ordered manner, and that is not something is not true. So therefore, you have to build a whole bunch of code to basically be resilient to that problem, and also to be resilient to let the customers know the reason why this isn't working right now is because GitHub is broken.
And then I guess perhaps to your point earlier, you're a little bit, as you build, this is one of those products where as you build it, you're at the whim of your own maturity. Until you feel fully mature, you're like, is this our fault or someone else's fault?
Yeah, always. If a customer has a problem here, the first thing should be like, let's make sure it's not our fault and let's help the customer. If it's our fault, fix it really quickly. If it's not our fault, let's help the customer understand why, and also what can we improve in the products that the customer doesn't next time think it might be our fault.
Yeah, that's interesting, because it puts you on the path for product quality anyways, because the whole point of such a system is to like prevent the customer from screwing themselves over.
Yeah. Also, this is mission critical system. It's it is directly in the line of fire of every single engineer trying to get their job done. So this has to be online as reliable as any other part of their coding system.
Yeah. And then even like and have hooks if they have some sort of emergency or whatever the hell is going on in their org, and be reactive to a lot of different things. Yeah. The sustainably broken build system is
that builds are not for the faint of heart.
I guess it's interesting because it's like the interaction between developers seems like more critical path than any individual developer's system or machine.
Yeah.
Right? Have you seen workloads change as people are employing more AI-based coding tools, and has that impacted the product or product definition?
Yeah, absolutely. We are seeing a lot more load. Like the amount of pull requests that organizations are pushing through is higher than ever. And that is actually leading more of them to want to adopt the merge queue. Like as you hit scale, information, the merge queue is basically designed to protect you against stale CI data. So if two pull requests basically test against different versions of main, they can have conflicting information. They could both think everything's going to be fine. Then when they land together, everything is not fine. That's what the merge queue is for. As agentic engineers and other bots are basically introducing more and more code, well, now we have a greater volume of an opportunity for conflict. So we've seen a growth in this product for sure.
Has that unearthed, or like maybe generally, do you have to ever go back to customers and be like, your CI system is just not robust enough to go to the next level of like of getting merges in? Or
so we've never had like a problem be like, you just can't land anything. It's mostly been like early on, we'll have conversations with customers where we'll be like, okay, walk us through your systems. We can understand your flow and how we can. And there definitely have been like 1 or 2 customers who were just like, the way you guys are working is so non-idiomatic that this would not be the right product. Like you're not doing, mostly merge queues are being used in, standard, modern dev Git flow, where there's a main branch, everyone's working in that. I think people are landing their code into that branch after, unit and integration tests pass. Some organizations are still, more, building code like we built in the 80s or 90s, where code is manually tested, everything gets, thrown into the thing. As long as it builds, it's fine. Yeah. That's, not the right time for this kind of product.
Yeah.
But there are fewer STEM days. They're very large.
Have you seen customers adapting or changing as they, other than just more PRs coming through, or are other parts of their system adapting to the amount of code they're driving from AI-based stuff?
I think, the companies that have really adopted AI, first, or, as a, to improve their engineering flows we're definitely seeing them also migrating to, more modern tools. Maybe they're moving from a legacy Jenkins deployment to GitHub Actions or to Build Kite or Circle CI, whatever it might be. So we're definitely seeing just overall, we'll start engaging with companies as they're doing a platform upgrade. Yeah. They might have been on top of Garrett or Build Bucket, and they're going to move to GitHub. And at the same time, they're going to be, changing over how they want to build code.
Yeah, I guess, and also I imagine like if they're pushing more PRs and you are now able to merge them a lot quicker, they're finding new bottlenecks. Like if their build is too flaky or taking too long, suddenly like that becomes a much bigger problem.
Yeah, there's great segue to the other piece of our platform, the Flaky test product, which is really all about tracking, the reliability of your tests, right? So when we say a Flaky test, what does that mean? It's a test that is inside your system and it will give you false negatives. So it will fail, even though this test actually, did not fail because of the code. Like the test is not reliable. Sometimes this is related to a timing issue, infrastructure issue, noisy neighbor issue, where you're trying to run a test alongside 500 other tests and the CPU literally just doesn't have enough, time to do all of its work to run all those tests. So when you get into those situations, this is like, I'd say, the greatest like vampiric action on engineering productivity. Like engineers are writing code, and then the tests are supposed to tell them if what they did is right or not. And now what actually happens is the tests become unreliable. They'll say, this thing failed. And a junior engineer, or I would say even more an agentic engineer, is going to be like, oh, I broke it. Everything in main is supposed to work. If something broke, it's my fault. So, I say like agentic engineers are like puppies. LLMs are like, oh, it must be my fault. You tell me I was wrong. I'm like, oh, sorry about that. Like when something breaks in a pull request and an agent opened, it doesn't know that it was not at fault. Yeah. So it's going to go until the
change something. Yeah.
Change something. Keep going. Eventually be like, the way to fix this test is to delete it. We've actually had the LLMs be like, oh, this test is problematic. I deleted it. You're all good to go. It's like, that's not really our intention here. So I think that, the Flaky test system we've built basically records the historical patterns of all your tests. So we understand this is the test, this is how reliable it is. And when it fails in a Flaky manner, this is actually what it'll output. So we can start to record a history and kind of understand the contextual history of every single test as it's run in different ways. Because when tests are run in PRs versus a merge queue versus maybe in a nightly, those are all different potential running situations. Like the resources allocated, the amount of load, they can all be different. They can fail in different ways. We'll keep track of all that and allow organizations to basically quarantine their failures. So if a test that is known to be buggy, to be flaky, fails in this flaky way, we're not going to tell the engineer you can't land our code. We're going to say like, actually, the only problems with this CI run were these flaky systems. We're going to ignore them and we're going to let you keep going forward. And that has unlocked massive productivity at some of our larger companies like Zillow and Brex all use these products.
Yeah, that makes sense. I mean, that seems, but I guess it was kind of a process probably to define flakiness. So there might be some more to unpack there, both because some of it always feels random and some of it does feel very context dependent. Like the overnight does something to bootstraps differently. And then once in a while, Flaky test is just a very esoteric bug.
Yes. Yeah, 100%. And again, this goes to tunability. As soon as you give a product to engineering organizations of more than one, they'll want to change how flakiness is defined. And so the tool also allows you to say, we have organizations that are like, if this thing fails once, it's flaky and main. Or they'll be like, if it fails 20 times, it's flaky. And they can tune those numbers. They can decide and have the tool work the way they want to. We don't try to dictate how organizations build their code or run their systems. We're giving them tools because they have very capable developer platform teams that can go and use our tools and tune them in a way that matches their development style. But I'd say like the coolest thing we've seen actually of late, and this is kind of like in this AI world, is taking the output of this information and feeding it back to agentic engineers. So into a cursor loop in agent mode or into Claude code. And we're doing this experiment actually this week where we said, okay, let's say a test fails. We have a flaky test. How would you normally fix it? Well, the first thing engineers can do is be like, let me look at historically how this thing ran. So, we already have that information, obviously. So we said, okay, what if we took that information and provided it to an agent? So we built access through an MCP to where you can basically inside Claude or inside Cursor be like, hey, Trunk, this test is flaky. Help me fix it. And we will actually throw into that context window for Cursor or Claude all the information around how this test has failed historically, what the CI logs around that piece were, what the failure messaging was. And it's amazing to actually see that light up change for how the agent tries to solve the problem. Like this is like getting really in the weeds, but we had this like test that resolved around 10 rows showing up in a table, and those records all had matching timestamps. So what happened was, if you fed that failure information just straight up into Cursor, it's gonna be like, oh, the way to fix this is timing. So we'll just put a wait and sleep, and everything will be better. It's actually not going to ever fix it because that's actually not what's happening. It happens to do with the ordering of the records. When we fed in our MCP, contextual information to Cursor and said, actually, when you're trying to solve it, here's some information around how this thing actually has failed, it got the solution perfectly. And it was like wild. I was like, this is exactly why we're building this tool on the next phase of our development, is to say, how do we empower agentic engineers to fix things that are flaky or even understand that it is flaky? So you say, hey, this thing failed. The agent should be able to be like, well, that actually has always been flaky, so I'm not going to look at that. So this is the next step of the evolution of the Trunk platform. And it was really cool this week to see it. We saw both with Claude and with Cursor, and we're looking through all the different agentic engineers to show them, with this information, you'll be a better engineer, both humans and bots.
Yeah, that makes a lot of sense. I've been talking to a few other people in the portfolio lately about how what they notice is like, on the one hand, it feels like things like all these vibe coding and coding platforms can kind of code whatever. On the other hand, they get these like things wrong all the time. And I got the sentiment, the mental model where it's like, what a really good engineer is doing most of the time is like, you see them doing the positive case of like implementing something, but most of their work is like the negative case of pruning what not to do. Yeah. And so like if the LLM knows what to do, it does it very well. Like it can execute very well, but it's not very good at pruning the search space and like especially in non-intuitive domains. It'll just do something random or like pick somewhere else. And so it does seem like being able to build up that context over time is going to be more and more valuable.
Yeah, I think that's spot on. I think like the first evolution of like going from early Copilot to early stage, later stage Cursor is like, once you actually have context of the repo, you can start writing code the right way. Early on, you see like, write this function, be like, that's not how we write code here. This just doesn't match at all. Cursor's like, big unlock was, I have access to the entire repository. I know how you write code. So I'm going to write this function in Python or TypeScript the way that the rest of the repo is written. Well, it's that context is always what matters to an LLM. And I think that bringing in test and CI context history is the next step where we basically can unlock for that whole SDLC to understand, here's how we write code. Here's what is actually unreliable. So when you agentically run the test to see what's actually happening, if you come across a failure, the first thing you should do is find out, has this failure ever been seen before in this test? If it has been, it's like, okay, well, that's not the problem of this code, right? And that, I think that short circuit is critical, because the long tail of making these tools really work well in real engineering, like larger, not just vibe coding, but something that's like a product that's supported by lots of users, so it doesn't accidentally delete your database, whatever it might be, like is having the full context of what's happening, understand the code and also the tests and the CI logs.
I guess how much internally have you guys leaned into AI-based coding? Is it like, is it an imperative you laid down, or is it just something you let the team organize around organically? Or
it's imperative. Everyone does it. We actually rebuilt our entire front end repository over the summer to be more easily coded by an agent. So the idea was making changes to the front end, which agents are like really great at, was very hard with our pre-existing code base, the way that we had laid out the structure. So we actually built the entire thing from scratch, using agents along the way to make sure that, Cursor or Vercel v0 could basically jump in, and we could take pieces of components and drop them in really quickly. So definitely on front end, AI is like part and parcel of the work nonstop. On our back end systems, it's definitely, not as useful. Like it just doesn't know how to write extremely efficient SQL queries or make things, understand the scale of the data, right? And that's really like where maybe that's the next frontier, or that's just a part that's so much more complicated, because it doesn't have historical data. It doesn't understand. There's a huge corpus of front end code out there to train on. Yeah. There's a huge corpus of, here's the SQL, here's how it works, here's actually how it's going to be affected by this index or this particular, sharding pattern. All of these things are outside of its scope right now. And if it doesn't have the context, I just don't think it could do a good job.
Yeah. And then I guess in that world, like how do you balance as an org that needs to move fast? Like, you could imagine that like you could go spend a bunch of cycles like building up a harness to give it the context you needed to get it moving faster on that specific end of the code base. You're also probably like expect the next generation of models to work a lot better. And so like how do you think about how much time to spend on tooling internally?
I think we try to build as little as possible because, as you said, I think the models will get better. I expect that ClickHouse will have, better understanding of models and data layout, and they'll be able to help us tune our, queries in the future. Like all of the, I think, if we learned anything in this build versus buy, it's like, if I can go buy something that was going to make this better, or can have one of our vendors make this thing better, I'd rather them do it than fix it in-house. Yeah. Because if I fix it in-house, then that's something I have to then go maintain, and it will go stale. Like it will stop working, and then, I've spent time and money on something that is not, my core goal.
Yeah, that makes a lot of sense. Do you have views? Like, I guess it's really interesting to hear more about like how individual developers' workflows are changing. But it seems like your product puts you in a very, very interesting seat in terms of like how orgs are going to continue to change. Like, where do you like? I imagine that's probably, and as part of the strategy of like of actually being in market right now. So like, what are your thoughts about like what's going to happen to software development orgs as the tooling gets better?
I think that as the tooling gets better, there will be a whole lot more code written. There's like there's no lack of need for more code to be written, or more product or more solutions to be built in software. Like it's, software is like the clay we can use to build all these amazing tools. And so I think that for software engineers who really understand how systems work, they have a massive future to just pump out tons of really interesting product and move really quickly. I want the pace of development should be greatly accelerated by not having to write your own for loops anymore, or any of those things, or even write large blocks of like UI layout code. That's just like not something that humans should be doing. So I think that software engineers, and even from my first touch of any of these systems was like, okay, now all good software engineers become conductors. We are conducting an orchestra of agents that are basically spinning code, and we have to understand when it's doing the right thing or the wrong thing, and making sure that when it's writing tests, that those tests are actually checking the situations that you're cognizant of in the right way. And all that work, is super high level, right? The conductor of an orchestra has a really hard job, has to keep everything in tune. And I think that's going to level up the job of those, really, strong, engineers to be able to be massively productive. Like the myth of the 10x engineer, like now you can actually be a 10x engineer. You can pump out so much code because you have all the things that were kind of rote or, that really could have been automated or not fixed for you. So it's really exciting to be an engineer because you get to focus on a thing that matters, which is building product. Yeah. It's not like how do I write this weird bash script to make sure that this thing's going to run? Like the LLM's going to do great work at that. You get to focus on the product.
Yeah, and I guess with your help, it seems like more focus on the product, but also in like more complex context, because it seems like there's even more. Like a lot of the first generation of the vibe coding things is just like go do something greenfield. That's like a unit that is functional and it's kind of amazing that now you can deploy a one-off app like immediately that does something useful for one person and changes the market for software, because like now you can do product that only has an audience of one. But also now we're seeing it come out the other end, where with like these very large code bases, very large organizations that can do a lot more things and a lot more concert, and like there's a lot more potential being possible. So it sounds like that's kind of like, that's what your company's oriented toward.
Yeah, working with organizations that have many engineers building complex, large systems that need to actually keep things moving as fast as possible. And that is like always my goal as an engineer, is just like make it faster. As every engineer wants to work faster, put out product faster. When no one is like, when the product manager comes and asks for a feature, if you're like, oh, that's going to take us 2 weeks, like that should just never be like, if that if I had a simple code base, I could do that in a day, then like that's the gap that we're trying to fix, right? Let's make sure that our larger systems can be as adaptable or as close as possible to that greenfield project. Because in a greenfield project, you could spin up massive, cool, complex website really quickly now, right? Real service. But, tweaking that and, with all the feature layers that come on top of it as it becomes a real product. Well, as it becomes a real product, can we still keep it agile? And I think that's always the tension inside software. It's like very hard to ship, versions and versions of Office over and over again and keep making them keep working. I think that with AI and with good tooling, we can actually keep systems agile while they're extremely complex.
Yeah. Which also sort of suggests we'll see more larger complex systems as like the complexity is now constrainable and understandable with the AI and, the ability to manage the repository.
Yeah. And really like the people are the ones, the engineers are the ones who have to think about how do all these systems actually interact, right? Because the AI, obviously early AI did silly things like, hey, I'm going to go pull in this library and go pull in a deprecated version of that library from like 3 years ago, because that was what it thought to do. Now they've gotten better because they have, a little more, I'm sure there's agentic looping to find out the latest version of a package before it pulls it down. But at the same way, our systems are complicated. And if, some company's going to release a new version of an API and you're trying to use it and launch with that thing, and there's going to be a release flag that has to be set, you can't just vibe code that. Like that's just, if you don't understand all those things, you're going to end up with a broken system, or you're going to launch something that doesn't work at day one. And I think that, software engineers, our jobs are not really just to write code, it's to build product. So understanding how all these systems work together, how they interact, what is actually happening in the external world that the agent doesn't know about.
Yeah. That makes a lot of sense. What should we look forward to seeing from Trunk?
I think the biggest piece is going to be, bringing this AI, enabling AI and enabling humans to use test and CI data to actually level up their code, to fix their flaky tests, to fix their broken things. I think that, just our initial tests of this in the lab have been amazingly cool. And I look forward to sharing more of those, videos and success moments, because when the agent can actually fix your flaky test in a way that like you wouldn't even have thought of because of all that context, that's a miracle. Like that's magic. Yeah. And I think when you have those magical moments with AI, you're just like, this is great.
Yeah, that's really exciting. It's going to make people's lives a bit better, because that is the part of the job that most makes you want to just pull your hair out. So
that's right. Oh, this thing is flaky. Okay, go fix it. Here's the information you need. Done.
Well, this has been really, really fascinating. Thanks a lot for spending the time.
Thanks for having me.